Begin. Thank you so much. Thank you for being with us here. Session is starting now. First of all, I want to thank you all for attending this year's edition of Science and Innovation Forum. This year's theme of the Science and Innovation Forum is focused on climate for action. And today, in this particular session, we will zoom in into artificial intelligence. FAO has been using the artificial intelligence for quite some time, even before we've seen the generative AI and a lot of focus, let's say, in this area. And we are proud to say so that some of these systems have been significantly already contributing to the climate action. Just most recently, we had good discussions and release of new vapor system, for example. And today, we would like to highlight and explore, through examples, solutions already in action, demonstrating potential of new digital technologies, and of course, with the focus of AI. AI has a pivotal role in building climate-resilient agri-food systems that are more efficient, sustainable, and adaptable to the challenges posed by changing climate. In the same time, it is important to take into consideration new issues emerging related to safe and ethical use of AI. We hope to spark the dialogue on how to enable sustainable agriculture and climate actions for adaptation, mitigation, and resilience driven by a safe use of data and technology to open path towards the agriculture of the future, harming no one and leaving no one behind. So today, I would like to also encourage you to join us in this dialogue, everyone who is in the room, but also who is joining online. We are using a social media wall to curate some of the questions and share experiences. We would not like to make this into a monologue, so please join us into discussing the AI and the use of AI towards climate action. So if you have any questions, please post. You can use your Twitter account, hashtag Digital4Impact. We will show the media wall screen after, so you can also scan the QR code if it makes it easier. So with that said, let's actually get us started. I have a great pleasure to invite our Director General of FAO, Mr. Q Dong-yu, to join us at the stage and have opening remarks. Yeah. DG, you have the floor.
Thank you.
Thank you.
Dear colleagues, good afternoon. I'm so happy to see here, but it's not interesting as that plenary hall. I always forgot I have a speaker out here, because if you go there, you get full energy. But here is so quiet, so serious. Yeah, we should create something, not, of course, not as warming as there, but we need the relaxed environment to discuss a serious topic. What is the AI? AI is not only scientists that talk about. AI should be applicable. Every day you use your mobile phone, and Google or Baidu, whatever, and their AI support us too. And find your preference, find something interesting, they will build up the big data behind to support you, to service you. So AI, it should be a tool, fit the purpose, especially for agri-food system transformation and rural development. That's why when I come here first time, I had a talk with him, the young. I said, he was the youngest director of the division I appointed. FAO and the UN almost play the game in the castle. They never access to the street, to the crowd, and never contact with the kids, young generation. They behave like a serious UN bureaucrat. And then nobody welcome you, you know. After so many years, 12 years, zero increase of budget, That's indicated that even members not support us. Why? We are left behind. We always talk about the no one leaving behind. Yesterday I learned from the honorable president of Ireland. He told me what is that sentence originated from and how the UN borrowed this sentence, leaving no one behind, leaving no one behind, and finally found ourselves leaving already far behind. That's the reality. Now everyone look at me. I create the attention first. Now I come to the real business. We need a digital FAO. We need a digital UN. We need a digital organization and a society, digital economy, because we are already in the digital world. And I know a lot of people, this room is not so many people. Online, I say more. You can imagine 5 years ago, 4 years ago in FAO, it's possible? No, it was only depend on the people that come here, they show their power. If I didn't come, so your meeting is not successful. I saw if I want to see how many people online, because you are AI session. That's one of the KPI and indicator to say that session is successful or not. You should use your own approach to evaluate your self-performance. That's AI application for your self-assessment first. Second, based on AI technology, it's important interlinkage with the biotechnology and other technology. And finally, we want to improve the efficiency and productivity and a more sustainable, more inclusive way to help our farmers to improve.
Good afternoon, Mr. Zahedi. Cara Michela.
Look. That never happened in other sessions, you see? That's your security, cyber security. So I always, in China, in any other place, I remember 4 years, 5 years ago, when I was in Germany, also for the global green city, and something wrong, because Germany was organized, everything is perfect. But when I come, something wrong. And now, never happened, maximum, like this. You are responsible for the digital FAO. So it has some hack. Some people really wanted to test it. They are much better than you know. That's the competition. So in short, we have designed all the tools, including AI. It's a tool. It's not a fancy to show. Keep other people understanding or didn't understand it. Behave like you are Superman, you are super scientist. No, we didn't know how to design a computer, but we need a friendly computer for us to use. AI is the same for agriculture. AI was not developed for agriculture and food, but how to adapt AI to the agri-food system and the rural demand, number one. Number two, how to upgrade the whole system of the agri-food system efficiency, effectiveness. Number two. Number three, how to help farmers to be organized, because 85% of the smallholder farmers on this planet, there are no real organization. They say they are farmers organization, no. Not like a trade union, they are very well organized. Through the digital approach, how to organize smallholder farmers, at least help them to improve their production, profitability, and to keep the agri-food system sustainable. Third, fourth, how FAO offer adequate, tangible service products. I said the service product. We are not a university, we are not an academy. We should offer tangible, concrete service products to the farmers organization, to help them. That's what we should do. Otherwise, all the digital FAO only for internal service. Yeah, it's very important. But my purpose, real goal, is through the digitalization of all the activities in FAO, and they reach to the digital society, to the digital economy in the rural areas. And for that, I wish all of you have an intensive discussion and come out with concrete suggestions to my colleagues to implement on the ground, especially FOR, online, a lot of FOR. You should get some digital solutions from CSI. Otherwise, CSI is only half success, because internally, digital FORs we are best in UN system. I'm very proud, yeah? But to reach the rural area, reach the members, we still not do enough. For that, I thank you all you can, and also especially DDG Nayara. Your whole life on nutrition and agricultural technology. Even you are staying the IAEA, it looks far distance from agriculture. But yourself, it's so close to agriculture technology. Thank you, thank you.
Thank you, DG. Thank you, DG. Thank you. Thank you, Director General. Thank you for giving us a boost of energy. We know that we have a very strong sense of urgency in what we need to do. We are, maybe seven harvests away before the 2030. So thank you, DG, for giving us the boost of energy. And maybe what we can do in this spirit, play a little video, just to maybe get more inspiration going in the room. So if I can ask for the video, please. Thank you very much. And in the meantime, I hope you had the opportunity to see the social media wall, and not only see it, but actually use the hashtag or scan the QR code. We have next our chief economist. Okay, sorry, I didn't see you. Maximo Torero, I have a pleasure to invite you to the stage and give us your opening remarks on AI. Thank you.
Thank you all for being here, and it's a pleasure to do the first presentation in this meeting. You know, people can talk from the space in these days, and we have to be ready. So the idea of today is to try to see how AI can help us in the digital food for resilient agri-food systems. And the first thing is to understand, if you can put the slides please, to understand the challenges that we are facing and what we need to do. And clearly, we have been working enormously in showing all the problems and how many people are in hunger. By 2030, 670 million people will be in chronic undernourishment, and we need to do significant work also to increase resilience. And here is where AI can play a huge role. When we talk about resilience, we are talking of two things basically. One is preventive, and that's early warning tools. An early warning tools needs to first predict something, tell you what will happen in the future, and second, to move fast, because then if not, the future is past. And that's where AI can play a role, help us in doing and analyzing enormous amount of data with supercomputers so that we can move forward, but also in trying to bring solutions that will help us to expand as quickly as possible those early warning tools. Now, when you have these alerts for tsunami, which are based on sensors in the sea, in the deep sea, and alert us in time so that people can move out. The same happens with food, flooding, droughts. Many problems that we are observing today in food can be accelerated through this process. We are even today working with a new underwater cables to try to put sensors also to help us to look at potential problems of weather and climate, because that's where we can figure it out in early times. So there is enormous amount of data, but there is also the capabilities to be able to accelerate this process and to show us how we can build these early warning tools. So that's the first component. And the second component is to have capacity of absorption. And to have capacity of absorption in resilience means that we are prepared and we are efficient in the way we produce. But people are a little bit concerned about AI because it's moving extremely fast. Every night I have to look at things, and the velocity in which they are moving is enormous. But this is like a wild horse, no? It can run everywhere. But it will be intelligent as much as we put intelligence into it. Still, the human beings have an advantage, and that's why we need to work to try to control that horse. I was just in Spain in a beautiful place of horses and how they are trained, and that's what we need to do. We cannot ignore it because it will eat us if we ignore it. We need to play with them, and we need to be able to manage them properly so that we can benefit from it and gain all the externalities, of course, respecting the ethical issues. We at FAO have been working in many ways and tools to try to start this process and use digital transformation, as the Director General was saying, through different mechanisms. The Hand in Hand, which is one of the forums in this week, is looking at geospatial information. And we are now bringing an enormous amount of geospatial information, even real-time information that is helping countries to make decisions in their territories at a subnational level. That's the whole trick of Hand in Hand. We do territorial approaches with geospatial, very detailed information and technology behind through stochastic frontiers that allow us to do that. We have tools like the WAPOR that was being exposed downstairs, which also help us to look at the water management and look at preventive issues of potential stress of water. CEPAL, ASIS, VIEWS, many other tools. We just launched the FLAP, the Food Loss app that was launched 2 weeks ago, which is a way to crowdsource information on food losses across the value chain. This will make a big difference for us and for the world because it will help us to identify where losses are happening and how we can put solutions, because we were completely misled of where losses were happening. Most of the investment was in post-harvest, in storage. And what we find now is that's not the problem. The problem is even before the post-harvest section. And that's where we need to work together and trying to find ways. We're working with the IAA on aflatoxins and testing aflatoxins in an efficient, high-quality way and cheaper way so that we can reduce that major problem. Again, using all this technology and information could help us enormously to move up. But we also need to scale up solutions. If we don't scale up, we are not going to get the impact that we were talking. It's not just to create the beautiful app, it's to put all the effort possible to be able to scale up. And digital is that. It's a cost-effective way to scale up things extremely fast. I can do a change in an Excel sheet and I can send messages to billions of people by pressing a button. Now, I hope my message is correct. Because if my message is incorrect, I create a big mess. But that's what we can do with AI. And this is not so new. We can go even faster. But we need to work and try to get the best possible information from what we do. Let me show you a little video of this experience that we have on digital agricultural services at hand.
Organic Ganjani, which is the local name for the digital services portfolio that is being provided by FAO, is a system that enables sharing and of information mainly related to agricultural production. So Organic Ganjani is really a good innovation that has come at the right time when we're in the middle of climate change impact and weather variation. I'm saying so because we have been experiencing changes in the agricultural season in the country. They are not starting as the way they should, the way they have been expected by many in the country. So using Organic Ganjani, you can know when is the right time for you to start land preparation, because you can get access of the information once it is released by the relevant authority, but also advisory on whether it is good time for you to start land preparation or not start land preparation. On top of this, Organic Ganjani is providing 10 days forecast and advisory, which is very much relevant to farmers, especially in the recent times we have been experiencing out of season rains, on which you might be expecting your crops to be drying in the field, and then there comes rain, and then it can really spoil all the crops in the field. So in relation to climate change, this has been helpful because it has been helping farmers and the livestock keeper to understand what to do based on weather variation that they are experiencing, and what is the right terms of action to be taken in order for them to keep their harvest at any time within the year.
So, colleagues, FAO needs to be at the frontier. There is no way out of this if we really want to achieve the agri-food system transformation. Imagine a system where a farmer, which is a poor small farmer, can take a picture of the disease he sees in his plant, and automatically there are tons of solutions that come to it, and FAO can play a role in certifying which is the proper solution. But that has to happen in seconds. Imagine a system that you can get your local prices on time, on real time. Not the prices of the wholesale market, which is useless for farmers living in little towns. They care about the price of their local market. Imagine a system where we can provide assistance, like what we are seeing in Kenya, a system that we can give us solutions of technology and improvement. Of course, it will require to have the supply, no? Because if the solution is a solution that requires to buy inputs and the inputs don't exist, we will have a problem. But at least we can accelerate, because at the end of the line, what we want is precision farming for smallholders. And our job is to provide public goods. Large farms will have precision farming. They will have sophisticated tractors with connection to the digital technologies, connected to satellites. They will do soil maps every day, have precision on how much pesticides, how much fertilizers, and what to do. Small farmers need to have the same access. And I think we can do it, and that's where AI and supercomputers can help us enormously to assure that. And we are progressing a lot, but we are still far, and we need to hang the horse, because the horse is running too fast. We need to get hold of it, and we need to work together to try to achieve that. And that will require also that we empower our rural communities and try to bring the knowledge from them. This has to be a bottom-up approach. That's the crowdsourcing of information. That's what we are doing with the FLAP, the Food Loss app. We need to have the tools, but be able to respond to the local demands and to provide the solutions that are scientifically proven to that local demands. If we don't bring the science and the evidence, we can mislead them, and that's the last thing we want. And that's where the intelligence of artificial intelligence happens. If we have good content, then we can do a lot more. But if our initial content is wrong, then we could create a problem. That's why it's so important that we work together to collaborate for action. And we're trying to link with all our partners, with ITU, with UNESCO, with the UN, with the Atomic Agency, every partner we can, because we cannot do this alone. We have to link to supercomputers in universities, in private agencies, so that we can have the capacity to process all this in the fast velocity that we need. So please, let's work together, and thank you so much for joining us today.
Thank you, Maximo. Thank you, Maximo, very much, and thank you for setting us the stage. And you cover a lot of different aspects, and in fact, it's a perfect introduction into our panel, because our panelists come from such a different background and representing different areas. And indeed, what does it take? What does it take, as our DG said, to reach the rural communities and leave no one behind? So we are ready to start the second section of our event. I will just move so I can see my panelists. So we have a fantastic panel with us today. Thank you for joining. I propose we start right away, because time is short. I have with us here Najat Mokhtar, the Deputy Director General and Head of Nuclear Sciences and Applications of International Atomic Energy Agency. So thank you so much for being with us today.
Pleasure.
FAO and IAEA have a very strong and long relationship. We have the joint labs. I learned that since 1964. Mm-hmm. So we are looking at 60 years almost. And the relationship is going strong. And yesterday we had also a very significant announcement that I'm really pleased to also repeat here from the Director General of the Atomic Agency about atoms for food. And this is very symbolic and in the right time. So we are very excited about that. And it's not, I would say, in the same spirit as RDG and Maximo, it's fully action-oriented. Mm. It was not an announcement of a general intent, but actually we could see the 7 points and a lot of action. So we have really a good energy to continue there together. So thank you for that. Coming back to our session, and very specifically on AI, we know that nuclear applications are very keen and extremely active around AI. So if we can hear also from you your thoughts around this.
Thank you, and very good afternoon to all of you, and happy to be here and discuss with this very hot topic and timely. And I think most of you, I don't know how much you know about the agency. You hear about the agency when we talk about in the news, but exactly we have almost 60 years collaboration with FAO. We have a FAO IA Joint Center where we do activities on food security throughout the value chain. I always say from the farm to the fork. So from soil and water, plant breeding, animal health, food safety, sterile insect technique, etc. But now coming to the subject, and just following what Massimo has just said about AI's tool, that we need to use it properly with ethical and with responsibility. And when you think about it, we are all talking about data, and Massimo has said that is we need to have quality data. It's about entering a big data to superpower computer to get some information that will accelerate the process of food security, whatever you want to look at water management or emergency management or anything else. But if you put in rubbish, you will get rubbish at the end, and you will have wrong information. So just to say how much is important the quality, the input that you put in that system or in the AI process. And this is where agency or the IAEA comes on board with nuclear technology. We are talking about a technology that has already been proven very robust, very reliable, and the data that we have, we bring in our data that you can rely on to really look at the outcome with complete confidence that you will get what you want. So having said that, now, what we are doing in this, just if you allow me to give a couple of examples. For example, we use isotope hydrology, isotope to really look at the management, look at the precipitation. We use, each thing in the world, everything in the nature has what we call fingerprint in isotopes. And we have the largest database on precipitations, for example. And this database, if you use it properly and you enter it into the system, you will have data on flooding, on when the precipitation will come, and it's huge information there on the drought, on anything you need. And that's why AI in that aspect is very important. And that's why we joined, you mentioned the Innovation Factory, which has been initiated, I think, a couple of years ago by ITU, the International Telecommunication Union, right? And this is just to provide this platform for matchmaking, to bring the data providers with the problem owners, and to try to solve this and also with AI specialists to try to solve this. And this is where we IEA, with FAO, with the World Bank, with ITU, UNESCO, we came together to this, what we call Innovation Factory, to use this platform, which is AI for Good platform, and to be able to say, okay, we have this database. How can you, AI specialists or computer specialists, can help us to get the most of it? So that's an example where we are now, we have already launched the call. It's kind of crowdsourcing. And then when we have already some applications, and we are going to announce this at the COP28, the winner. We are taking the winner to COP28. Just to give you an example that, from my perspective, AI is here to stay, and it's here to be used as, so we need to use the most of it to be able to accelerate all things that we are seeing, climate change, food insecurity, water insecurity, etc. So we have to use it properly with responsibility. And then the next question, which I have 1 more minute, is about, okay, all this is very good, but like what DG said also in his introductory remarks, is how to make this accessible to the farmers there in the rural area. And here again, each farmer has more sophisticated telephone than mine. So then we need to really make sure that this information be simplified and being accessible. Mm-hmm. And this is what we are doing as well, is making sure that what we get from using artificial intelligence is to use it simply, for example, telephone-based or etc., to be accessible to the farmers. And then maybe I will give a few examples later on.
Yeah, maybe I can, in fact, you picked our interest here. AI, technology, nuclear, food and agriculture.
Mm-hmm. Doesn't match?
Well, it matches, but it would be fantastic to see maybe an example where we can bring it closer to our audience.
Okay, I gave already the example on precipitation, but as I've said, it's one of the largest. database that we are collecting from all over the world, and it has, I think, more than 60 years. But on agriculture, and particularly in the Joint Center, FAO Joint Center, as I have said, we are applying the technology throughout the value chain. And if you look at soil and water, for example, I take this this topic, nuclear technology, we're using a technology called neutron cosmic ray technology, which use cosmic rays to measure the neutrons, and these measurements give you the amount of water in the soil. So it's technology that can give you the moisture of the soil in larger area. So it's kind of sensors that you put everywhere, and you collect this data using satellite information, and we bring this to, again, to analysis to see, to bring it to the farmers through an application to tell them when they can irrigate or not irrigate. This is very crucial, very important to in area where water is scarce and it needs to be managed very well. So this is one of the examples. Another example is, for example, I think Massimo, who mentioned that about the animal diseases, and already FAO has this platform, but also which we are using also in IEA, is to make sure that we have on-time information on diseases everywhere. And this is by collecting the data, trying to do the surveillance and try to also make kind of predict what's going to happen, and also inform the farmers early enough to be vigilant. So this is kind of data that we are collecting and bringing this to the farmers level.
Thank you so much. But indeed, and very much in line actually with our general theme on water, as you mentioned the example. So it fits very well. Thank you. I hope this brought a little bit closer this whole. We can demystify a little bit how connect AI and technology, digital transformation, the nuclear, the power of nuclear and usability, and how do we tie that to really reimagining even the agri-food systems of the future and enabling the farmers to take advantage.
Absolutely. And if you allow me another example, for example, food fraud. Each food has also isotopic fingerprint. So we, together with FAO, we developed this database on food authenticity, or olive oil, for example. So you have different olive oil, and depend on where that olive trees are, you have this fingerprint of the olive. So we developed this huge database, and then together we developed sensors that you can only measure immediately on a sample of oil, so it can tell you where that oil is coming from, or if the labeling is authentic or not. So that's very important to assess the fraudulence of food.
Yeah, absolutely. Thank you. And this reminds me of my visit to the labs, and where I was really
you have
pleased
been
to
there,
see.
right?
Yes, I have been. But I want to also share that perhaps it's not well known that Atomic Agency does way more than tests around the nuclear facilities and etc. And the labs are very impressive. And I was fortunate enough to see the actual the labs, and not only in the area of counterfeit food, but also mosquito control and others.
Absolutely.
So thank you so much.
Yeah, thank you.
We also have here with us our FAO Director of Office of Innovation, Vincent Martin. Thank you for being with us. It's a busy week for you. This whole week is around science, technology, innovation. So thank you for joining us here for a discussion on AI. I wanted to also ask you, how do you see, where do we fit? What is AI? And we have the climate change, and we have innovation and technology, science. Can you share with us your thoughts?
Sure. Yeah, thank you very much, Dejan, for inviting me. Yeah, I would like to share a few reflections. I'm not an expert in AI, but of course we are embracing artificial intelligence in our Office of Innovation, and we are working hand in hand with my friend Dejan, with his department, to look at all the possibilities offered by artificial intelligence. My first reflection, generic one, is AI has become a real buzzword. Everybody talks about AI, and we are all kind of running after it. And I like the metaphor of Maximo saying it's a kind of wild horse, and we need to understand how can we ride this wild horse and maybe catch up with it and make it more a domestic horse. So that's something that I think is important. And I see that we are talking about AI and it's about everything and nothing. I think there is a need to understand a little bit better to the scope of what is AI in agriculture, what is AI in agri-food systems. And that's really something, by having a right definition, by understanding what is the perimeter in which we are talking about, I think it will help us to have the right conversation as well and to delimit where we are in this field and where we want to go. And I think this is what FAO is doing at the moment, working on a specific paper on artificial intelligence in agri-food systems to define our position. I think it's really something which is missing and which is extremely important. And so that's my first reflection. My second reflection is, of course, to say we embrace artificial intelligence because we think it's a beacon of hope. I think in innovation, it's one of the innovations we need to use. It's really something we need to tap into because it has an incredible potential. That is very clear. It was mentioned by the DG, by Maximo, by Najat. I think we all agree on that. And we can see a huge potential also for reducing the labor. Agriculture is labor intensive. Artificial intelligence can really help in that. Second, artificial intelligence can really attract young people. By using these new technologies, digitalization, artificial intelligence, it has the power of offering opportunities to the youth that they don't necessarily have today or they don't see in agriculture. But they could see it if they really understand all the what is offered by artificial intelligence. And then when you talk about climate change, you cannot talk about artificial intelligence, accelerating progress, addressing this challenge without talking about artificial intelligence. It's the chance we have to really address climate change issues. And there are many examples, the one that were mentioned by Najat on using, how you call it, it's cosmic ray neutron sensors. I had picked up this example because I think it's absolutely fantastic. Some of these examples related to precision agriculture that are game changers. By using such technologies, it's cheap, it's relatively cheap. You can train farmers to use it. It's not so complicated. And you can scale it up. The notion of scale was mentioned before. It's really important. So by leveraging artificial intelligence, we have the capacity really to address these issues. And it's just a necessity. We need to embrace it. Having said that, maybe there are two more things I wanted to mention, and it has already been mentioned. Well, the first thing is, okay, we are in FAO, we are embracing artificial intelligence. We've just created a community of practice on artificial intelligence, which is growing in numbers, exactly to address the issue that was mentioned before about ethics and responsibility. We cannot talk about artificial intelligence and digitalization without addressing this issue. And that's why I was saying understanding the perimeter, understanding what we are talking about is important so that we can also put the right words on this issue of responsibility and ethics. And here, one thing that we realized through our conversation in FAO is that there are a lot of bias that can come with artificial intelligence. We have to be very, very aware of, by using large amount of data which have not been tested in some specific context, we might exclude more people. We might have a gender bias. We might have other types of biases that we don't want, discrimination that we don't want to see. So when we are talking about leaving no one behind, that we need to keep in mind, I think the problem behind it is these biases that could be created by artificial intelligence. And as we say, and I will say it in a less polite way that has been said before, as we say in terms of data, it's garbage in and garbage out. So if we don't have the right data, and it's a big issue, the data across the world, if we don't have the right data to train these models, then we will just create more biases, we will just create more digital divide. So that's really, really, really important. And then, of course, coming with that, there is the issue of policy and regulatory framework. So we need to understand all these so that we can embrace it, but we can embrace it with caution, making sure that we are not creating more divide, but we are really being inclusive in the way we are offering these techniques. One last word, and I think we will come back on some, there might be an additional question, but what I like also in artificial intelligence, we tend to think of artificial intelligence and digitalization as something very high-tech. But, and I'm sure, Rinkin, this is what he's going to talk about, artificial intelligence can be used for simple innovation, frugal innovation, doing something simple in the field that is inclusive, because you can use multiple languages, for example, and that is extremely useful for farmers by using the technologies we have today. So artificial intelligence is not equal necessarily to a high-tech type of innovation. It can be somehow, I mean, it comes from high-tech, but it can become something very frugal and simple in its application.
Thank you so much, and indeed, this is a great reflection. So we are consistently saying, yes, AI, help us, but let's do it responsibly. And the dimension around data is a very interesting one. We tend to focus on data in terms of data quality. Can we actually have the proper result coming out more, how to say, mathematically? But here, there is something more deep here, right? The inclusivity, possibly gender bias. There are all kinds of issues there with data that were maybe not as obvious before. So thank you for bringing this up. And you also mentioned ethics. Can you tell us a little bit more? Can we zoom in a little bit more on ethics and ethical use of AI?
I can do that. Yeah. But maybe just before saying that, there is one concept which is important for me as well, is the concept of co-designing solutions together. This is something, I've been in FAO for, I would almost say 100 years, but it's not true, like 25 years is enough. I've been in the UN for a very, very long time, and when I was younger, I was developing applications for farmers, for livestock owners, trying to prevent animal diseases. I was working on epidemic diseases. And one thing that I've realized, and we failed sometimes we failed because we were assuming we knew what people needed, what were the gaps in the field, and then we were designing applications, digital solutions that at the end of the day were not necessarily used, and it was a waste of resources. So that's really something that we are promoting in the Office of Innovation, this principle of co-innovation, co-design of solutions with the end users, basically. And I think that is really something which is extremely important. Otherwise, we can develop all sorts of nice tools that are not going to be used. That was something I wanted to mention. On the ethics part, so I mentioned the bias and so on and so forth. I wanted to mention the Rome Call for AI Ethics that was signed by FAO, by IBM, and by Microsoft, and it was endorsed by the Pope. And I think this is our framework, that's our basis for walking the talk of what does it mean to be responsible and ethical in the area of artificial intelligence. And I'm just going to read one or two sentences on this one. So the Rome Call, there are several principles in this Rome Call for AI ethics. And one of them is that AI system must be explainable, it must be inclusive, so that the needs of all human beings are taken into account, and they are offered the best possible conditions to express themselves and develop, and impartiality, so that such technology do not create or act according to bias to the advantage of just a few. So I think it's just recall a little bit what we were saying, and just another thing to recall is that there is also this need to bridge the digital divide. There are 6 billion people which are without broadband today. 4 billion without internet, 2 billion without mobile phones, and 400 million people are without a digital signal. And there are significant gaps in access to resources between men and women, young and old. I think that's very important to keep it in mind that, yes, true, many people have their smartphones in the most remote places. I've been in Africa, in Asia. It is true, but we shouldn't overlook the fact that there are still many people who don't have it, and there are still some gaps in terms of gender, in terms of youth and old, in terms of access to this technology. So what I suggest is that from this AI call for AI call for ethics, we move it to something very concrete and pragmatical, and we have to define what it is that we can walk the talk.
Thanks a lot. So it's interesting. We tied together now the AI ethics and also the disadvantage, right? Because there is no connectivity or even what we usually call meaningful connectivity. So it's not only about connectivity, but actually having something in hand that's usable by the farmer, for example, right? So something that the farmers will have capacity to use and it's useful. And I think one of the examples was also from Maximo on can we scan a plant and get the immediate maybe advisory. We'll get to advisory. So thank you very much, Vincent. Thank you for this. We'll get to advisory just a little bit later. Our next panelist is online, and his name is Alan Belvard. I don't know if we have him connected. He's the head of the unit of food security from European Commission Joint Research Center. And unfortunately, Alan was, due to, I think there were some problems with the trains, could not join us here in person. But we are trying to use technology to overcome these logistical issues. And here it is. Hi, very good to see you. Hope you can hear us. Thanks for not giving up and still joining us.
Well, I think it's a good example from what the Director General said in his very opening remarks, isn't it? That we can adapt.
We can adapt, and definitely I like to see this as using digital for resilience. So thank you. Nothing can disturb our session here. So if I can also give you the floor to give us a perspective from our Joint Research Center, I will just say that FAO has a long history of working with the Joint Research Center. We have many joint projects on digitalization and Earth observation and really utilizing the data jointly to be able to enable new capabilities. And these capabilities sometimes are used by the stakeholders, very often by our member states, but also with the farmers directly. So if I can give the floor to you, Alan, go ahead.
Yeah, thank you very much. Yes, indeed, we have a very long history of working together. And the European Commission, the Joint Research Centre, particularly to serve the other policy-making bits of the JRC, has a very long history, 30 years or more, of using digital technologies for this. It falls into, maybe as far as the food area is concerned, right now, monthly crop forecasts for the whole of the European Union and for many neighbouring regions, which rely very heavily on geospatial data, whether that's agrometeorological or satellite image. We use similar technology for agricultural production anomalies in food insecure parts of the world. So it's not just looking at the European Union. But then coming back to the European Union, we use it intensely on a very, very detailed level in a legal framework, really, for looking at compliance and assurance, for monitoring, for looking at the performance of the payments related to the common agriculture policy. So it has a well-established use in our policy world. We see three main trends emerging in terms of the digital world. The first has already been mentioned by Maximo. It's the access to finance and markets. The second area, the first, we're not so much involved in that as a group, but there is strong interest in it. The second is on optimization at the individual farm level, precision farming, which you just mentioned, and also the farm advisory services. And then the third domain, which is much more our specific area, is on the sort of monitoring, reporting, and verification world. And this can be at any scale, from a region to a nation to a continent and indeed global. As we've got more advanced in using these stacks of data, which when I first started in it, you had to choose between using time and space, and now you can use both. So you can look at anywhere on the planet in a huge amount of detail practically every day. And that's leading to huge advances in terms of the information that we can provide. But one thing we notice consistently is that AI is hungry. It's hungry for data, it's hungry for processes, and it tends to be mainly used in data-rich environments. And one of the things that we're actively pursuing with yourselves in FAO, with the University of Valencia and our team here at the JRC, is to try and look at ways in which AI can be used in more data poor, less rich environments. The satellite image stacks are pretty much universal, but the data that go with it are often not. And so we're trying to find ways in which we can harness the AI learning, the machine learning, to exploit what little data we can have to get the same results. And it's really improving crop yields in a number of countries where normal access to data has been somewhat limited. And because you can act so fast with it, it's giving us opportunities to test new models, to test new crop yield forecasting, to integrate the best bits of those models that we're looking at together. And also it's quite good now at explaining why we're getting the results that we're getting. So it's definitely leading to greater precision in the forecasts, and users at all levels, whether it's predictive capability or the actual numbers, which are getting more accurate. And that gives us decision makers more power, I think. I would conclude, I think, we've got 4 lessons, many of which you've heard. Quality assurance right from the start is absolutely crucial. As we've heard, garbage in, garbage out, rubbish in, rubbish out. You've really got to go, and don't even trust the huge stacks of satellite images that are there. They're not all good. You need to have quality assurance right from the start. Second lesson from us is validate the output. It's quite easy to run these things and produce statistics, produce a map, produce a forecast. If you don't know how good it is, you shouldn't be using it. The third lesson is we can always learn. We learn from each other. The Valencia FAO JRC partnership is a very rich one, but we recognize that we work with each other, not for each other, and that international partnership should expand and spread. And then the final thing is mandate. Who's actually got the mandate or the governance to produce these statistics and these measurements that we're talking about? And I think that's something we have to be very careful of, because the unwary can be offered very convincing looking results, which maybe don't come from a reliable source. And so I think it's very important to look at mandate too. So if we can cover quality assurance, validation, working together, and a decent mandate, then I agree that Maximo's wild horse can continue to run, and hopefully we can climb on board it with great efficiency. Thank you.
Thank you so much. Great summary, great summary. You introduced also one more maybe domain we need to address, which is the financial side of the, how technology and digital can help us with enabling farmers on that end as well. And this is significant as we see going digital actually enables farmers to have maybe access to financial products, insurance, and it's all one big ecosystem around that. You also mentioned something about the satellite imagery, and we know the Earth observation is one of the strong JRC features there. I have a follow-up question. Where do you see the greatest potential of AI and Earth observation in realizing European Green Deal related policies? Because the policies are also, how to say, the normative instruments we need in many circumstances around the world to be able to use the AI or not, right?
Yes. What's very interesting is a convergence of policy or a cross-dependence on policy. Our first speaker on the panel already introduced the name of one of our major new strategies, which is the farm to fork strategy. So we have farm to fork strategy, we have nature restoration law, we have climate law, we have a new soil monitoring directive, we have the common agricultural policy, of course. We have the sustainable use of pesticides. All these, climate law in terms of carbon removals from land, the common element is the land, and it's trying to attach a process or an outcome to a specific parcel of land. And I think that what will really come to the fore as we harness these stacks of data and the models to go with it is accountability and certification. I think that will give us much more, and that in turn gives you faith in or can give you more trust in the outcome of a policy. Because if you design a policy, say, to increase carbon capture, and then you're able to actually put a number and attach it to a particular piece of land which has had a particular activity associated with it, then that gives everybody confidence in the validity of the new policy. So that would be my answer. I think it's on that area, certification.
Excellent. Thank you so much. Thank you. I understand on our social media wall, we are already getting some questions. So I wanted to prompt if there are more questions, please don't be shy. Interact with us as we go through different areas and different contexts of AI. We also have here with us Sebastian Bosse. Thank you for being with us. Sebastian is head of Interactive and Cognitive Systems Group at Fraunhofer Heinrich Hertz Institute, HHI, right? And you're also working with us very actively, helping us within the UN family, let's call it this way. We have a focus group on artificial intelligence facilitated by ITU, International Telecommunications Union, and you're helping us with that project. But can you tell us from your perspective, what do you see? I mean, we covered kind of a lot of ground here already.
For having me here, and also thank you for all the interventions, all the reflections we heard before, because it's really nicely sets the tone what I want to say. For trying to bring the cloudy word of AI to the ground, because I think this is very important, and this relates to what you mentioned as well, like co-innovation. So as a researcher, something that
There is a...
What I see as a researcher is that at the one side, practitioners, farmers, they have quite a lot of expectations to AI. The researchers, they have quite a lot of curiosity on AI, but it doesn't really match. So it's really good to find ways, co-innovative ways, co-designing ways that basically takes into account both sides of the coins. I think that's crucial to make efforts and progress in the realm of agriculture using AI. So I think that in the last couple of days, we saw a lot of very exciting and promising use cases where we were shown that AI allows us to crunch large amounts of data and find patterns in that data that helps us to develop more climate resilient crop types, for example, to optimize our agricultural planning in response to changing environments, and to use robotics to operate time-critical agricultural interventions. We have drones monitoring crop health, AI predicting disease outbreaks, satellite-based forest monitoring, precision agriculture, in different sorts of different areas of the world. In Kenya, for example, we saw that farmers are using mobile apps to monitor crops, trees, livestock systems, and thereby decreasing the carbon emissions. And in the US, we have robots that are able to basically harvest lettuces. And I think that these solutions already bring us forward quite a bit in decoupling climate change and agriculture. But we can also see from these examples that the use of AI and the application field and the promises, maybe also sometimes false promises of it, have a very wide scope. And I think this is something very inherent to agriculture and different to all other sectors that I worked in so far. So the world obviously is not uniform. Its biophysical and community attributes are different from region to region, and agriculture is more unique in its local ecosystem. And being deeply rooted in the local ecosystem, this amplifies the challenge here. So this heterogeneity that we face has an economic aspect as well. We heard this before in the presentation of the General Director, that about 86% of all farms are smallholder farms with obviously totally different requirements when it comes to database solutions in their agricultural challenges. And this is not even mentioning the socio-cultural or social economic aspect here. You know this all, I guess. So why is this important when it comes to the question how we can leverage artificial intelligence and cognitive digital technologies in agriculture? So given the heterogeneity and high diversity of the world we are operating in and the character of the technology that we are using, we cannot really expect that the data that we are gathering in some regions of the world is really representative to be able to train models, to design models that are directly applicable to other parts of the world as well. So there won't be some sort of one-fits-all solution here. So we will not be able to train a model, say, I'm from Germany, so in Germany, I don't even think it's possible to train something there that works in Italy. And I guess that one promising avenue to establish, and this is something we heard in the presentation from Massimo as well, might be to establish technological platforms that connects farmers, machinery, AI in a very adaptive and user-centric fashion. So really taking into account the perspective of the actual practitioners here. This also means that we might not need like large land machines everywhere in the world. So this is something, the end user device is very, very important to consider with regard to what's actually the challenge on the field. And one could think as an embodiment of such a platform as some sort of app store, where farmers basically book suitable apps for applications in their concrete production systems, and maybe something like an analysis tool to detect yellow rust, or a tool to come up to a decision support from drone images for the optimal allocation of crops in the field. At the same time, farmers are enabled then to store data in an efficient and secure sense. This is important here, that we have to talk about data sovereignty as well. And then this can, in turn, if the farmer agrees, for example, sold to AI developers to come up with new and better models. This is different to what we see right now. So we have such platforms. We had such platforms, for example, I know from BASF, I know from John Deere, but those are basically a golden garden. Such an approach, an open platform, would enable and activate hopefully very rich and vivid ecosystem. We're exploring such approaches currently in Germany, where we have a research project. It's called Nalamki. If you're interested in that, I can give you some more information about that, where we are establishing such a platform with a wide range of use cases. And we do this, again, in a very user-centric way. So we really want to understand, okay, so we have orchard monitoring here, and we have yellow rust detection here. So what is the actual difference for the farmer that it's usable for him or her? And our results look quite promising. So we are lucky enough to have next year the opportunity to evaluate this in India as well, in Telangana. We will ship this out in Telangana and scale it there. So this gives us a good opportunity to understand the limits and potentials of such approaches. And it directly allows as well to plug in other services, other data types. This is all considered in the data structure that's sitting inside this platform. So like a tongue-in-cheek comparison could be, it's a plug-and-play operating system for agriculture. But there's a challenge to this. So obviously, such a platform has a lot of interfaces, because you have interfaces with the machinery, with the sensors, with the farmer, and you need the data so that the AI can do its magic, let's say, and produce the data products that you actually need at the farm level. And so this basically amounts to a word that we heard quite a bit of in the last couple of days as well, which is interoperability. So how can we actually achieve interoperability that such a, let's say, undiscriminatory system could come into existence? And I guess that here we we need very clear definitions of input and output and representations of data. AgroVoc, for example, is a very good foundation for that, I think, to find an ontology, a good representational ontology for this. But this needs to be pushed through the full stack of technology, from the sensor to the server, to the runtime environment of the AI, to the farmer, to the machinery. So we need some sort of common understanding of what data is actually, what is it actually that we are using, and we also need a very precise understanding of what data quality is. This is crucial here, and we know it's nothing that we can agree of by saying, okay, yeah, we need high quality data. We need to be able to measure this, so we need criterions of what we actually mean by good data. And one way forward here, like a very concrete forward, is what Dejan was alluding to previously, might be the ITU FAO activity, the focus group on AI and IoT for digital agriculture. So here one of our goals is to pinpoint where interoperability can benefit from standardization. And I think this is a very, very interesting and promising venue because with the expertise of the FAO in the agricultural domain and the ITU with its role as the only standard developing organization in the UN systems, this is a very valuable combination to move forward in this direction. So maybe it's a little too optimistic, but I also like the quote, so I just bring it. So there is this famous quote from William Gibson, "The future is already here, it's just not evenly distributed." And maybe we have such a situation in agriculture right now. We have a lot of distributed solutions and they showcase really nicely how much potential is there, and they bring very nice solutions in regions. But I think what we might push forward is a systematic evaluation how these things generalize and the technology to actually do this.
Thank you so much, and thank you for pointing out the diversity of needs of the farmers. There's so many different needs. We have farmers who are maybe focusing more on agriculture or cattle or everything, or fisheries even. So it's so diverse. You mentioned something about the platform. I wanted to ask you how the platform-based approach helps mitigate climate change, right? So looking today at the Science and Innovation Forum and the platform, and would you be able to connect to the climate change better than any maybe other approaches?
Yeah, so I guess that the platform is basically a means to scale solutions very quickly to different other areas. So we face this challenge here that we, for meaningful AI representations, we need a lot of data. At the same time, we have this high diversity. So even if we have a lot of data in Germany, we cannot use it in Italy, most likely. And if we have a platform that maybe in a first step is able to collect and organize such data so that it can be scaled and be usable in other areas as well, to collect it in reasonable amounts, this holds the potential to just push on the application of AI in agriculture in general. And then because you're very flexible and adaptable, then you can use this data to the local, let's say, challenges that you find, that you identified with relation to a mitigation of climate change things, and with regard to the impact of climate change coming from agriculture.
Thank you. So I definitely am looking forward to continue our collaboration, and in terms of the platform, it definitely gives me a good feeling of a direction we are taking also as FAO with the digital public goods and digital public infrastructures. Yeah. And I would say it's a very complementary, right? So we can support each other in building this digital public infrastructure and the digital public goods, so that we bring down the barrier for the farmers and the stakeholders for using the technology, so that we don't create too expensive of a tool or for some other reason unreachable. And when we say unreachable, it's a perfect, so thank you, Sebastian. It's a perfect actual introduction to our last panelist, Rikin Gandhi. Thank you for being with us. Rikin, you are CEO and co-founder of Digital Green. And we started our opening here with saying leave no one behind and making sure that what we do is relevant and it reaches the farmers and that we actually have a way to do it in a meaningful way and engage. You are right in that business, right? Can you tell us more?
Sure. Thank you so much for having me. Imagine you're an agricultural extension officer in Ethiopia, tasked with training coffee farmers on a climate-smart practice. Farms are remote and terrains are difficult to navigate. Rural communities are large and diverse. Even in a country like Ethiopia with more than 60,000 extension agents, it still is a daunting challenge. There's also the issue of motivation, both for farmers to trust an extension agent coming in from the outside and extension agents toiling in the sun, and in India finding that less than 2% of farmers actually trust them as a major source of information. At Digital Green, we've sought to flip that paradigm of agricultural extension. We did that first in India, Ethiopia, and Kenya with videos by farmers and for farmers. When a farmer sees these videos, the first question he or she asks is not about the economics of the practice, but rather, what's the name of the person in the video and which village is he or she from? With support from the World Bank, the Gates Foundation, we've scaled this use of participatory video now to more than 5 million farmers, 70% of whom are women, with ministries of agriculture across India, Ethiopia, and Kenya. We've seen the price for getting one farmer to adopt one practice go down from $35 in the conventional agricultural extension model, be taken down to $3.5, while increasing productivity and incomes. AI now offers a new paradigm shift. The opportunity with generative AI is that these local language videos that have been produced by this network of governments and community members can now be put into large language models and create an assistant to help extension agents as they triage issues with the farmers that they serve immediately on their farms. We see this opportunity to scale this approach to millions more farmers and reduce costs of extension by another factor of 10, perhaps from $3.50 to get one farmer to adopt one practice down to 35 cents. But it's not just AI that will magically make this happen. Investments in agricultural R&D by the FAO, CGIAR, National Ag Research Systems have built models that offer tailored advisories for site-specific fertilizer recommendations and targeted feed rations for dairy cattle. Government and private sector are already digitizing extension agent and farmer profiles with names, locations, gender, and crop livestock type of information. Generative AI offers the opportunity to integrate this data and content into a digital public infrastructure and deliver them in a conversational, natural language interface on popular messaging platforms, whether they be WhatsApp or even SMS. Extension agents can use voice notes in their local language and dialects and submit photos from the field and get responses in local language audio and video form in less than 10 seconds and give their feedback about whether that response was accurate or not. We've started this with extension agents as the primary user of this assistant to augment their work and to provide necessary safeguards for farmers to calibrate these AI models before taking them more widely to farmers directly. Linking these AI models to systems like registries of extension agents and farmers is so critical to ensure that the chatbot is customized based on location and season and does so with their explicit consent and with their privacy. The power of machine learning is its ability to gather feedback and data from extension agents and farmers with each interaction that they have with the assistant. Those interactions can then be used to dynamically update profile and registry data about what crops and livestock extension agents and farmers are interested in and the climate challenges that they're dealing with on the front lines. I encourage you to try out the bot firsthand for yourself by going to farmer.chat or scanning the QR code that you see on the screen. Unlike ChatGPT, which is trained on the whole of the internet, we use the underlying technology to train AI on location-specific content from well-established government and research centers, including videos by farmers themselves, reducing the risks of hallucinations and boosting the relevance of advisories. This assistant, powered by AI, can make local advisory accessible even to the most marginalized populations and communities. We're already seeing in our deployment employments that women extension agents actually use this bot 2 times more than their male counterparts, since they no longer need to travel to in-person training workshops. When women extension agents gain more knowledge, better represent the questions and interests of women farmers, we can more quickly close the gender gap that exists in extension. I'd like to call on us to think about establishing an agricultural advisory AI commons. Because of the need of AI to aggregate data and content from multiple sources, it's really important that we get ahead of this by thinking of a governance and a technical architecture that brings together governments and the farmers themselves, as well as organizations like the FAO, to maximize our collective impact and ensure that there are necessary governance and technical safeguards with both the power and the risks that AI represents. AI is, of course, no silver bullet, but when it's paired with well-intentioned organizations and farmers' own wisdoms, it can lead to a cascade of farmers taking many small steps toward a more resilient, profitable, and more food-secure future for all of us. Thank you very much.
Thank you so much. Thank you. So you're on the forefront with basically engaging with the farmers. How can you kind of bring together to us AI, the farmers, supporting them in remote areas, right? And then tied to climate change in these diverse rural communities, but also with a perspective from something that maybe farmers are worried about, like data consents. How does this whole engine work?
So I think the power of AI is that it used to be that each of these systems was considered independent. Extension over here, research over there, and data systems in a third place. We can now pull these systems all together into a much more interactive and more intuitive user interface, wherein even the most marginalized communities who may not even have access to a smartphone can, in local language voice or local language text, be able to express what is their questions that they have, what are the issues that they're facing, and be able to use that to inform policymakers, researchers about what kind of ground truth, real circumstances are these extension agents and farmers really facing on a day-to-day basis, and then be able to both improve these AI models, but also the larger agenda of food and nutrition security.
Thank you, thank you. All right, so we did a kind of a full circle here. Maybe what we can try now is to see if maybe panelist to panelist, we can inspire panelist to panelist dialogue. If there are any questions that we maybe inspired anyone, any volunteers? No? You? Go ahead.
I was curious for Sebastian. He mentioned, as did multiple people, about this issue about quality content, quality data. And I was curious to think about how does one establish what is the benchmark of quality. In our experience, we're trying to work at the extension agent and the farmer level to provide feedback about what's useful to them and what's not. But I was curious about what your experience has been.
So that's a very, very good and interesting question. So I guess if we talk about AI models, about data-driven AI models, then ultimately the most important thing is that the data that you get in terms of quality is representative for the data product that you want to have. So if you have, let's say, satellite imagery and there's a cloudy image, then you don't get any meaningful information out of it. So we can say that this information is, the quality of this specific sample is very low. And I guess that as far as I know, there is nothing like this. I think we need to come up with some sort of analytical standards, like some sort of algorithm, some sort of criterions that we agree on that is an indicator for quality. And from my point of view, the only way, if we are talking about adaptive systems, about learning systems, the only way forward would be not to talk about stuff like resolution, for example, but to talk about the feasibility of a specific sample to represent the information that is relevant for the application, meaning for the farmer.
No, thank you.
Yeah,
Go
just to add on what had just been said, in our case, data also are, they are related to the measurement that we are doing, and we need to make sure that the measurement's being done properly, and that's why we run regularly what we call proficiency testing, so that we align all those that they are giving us the data, that they are doing that correctly. So that's important to have kind of proficiency testing. Whatever you are measuring, it has to be checked.
So, no, thank you. But indeed, for the data, we are seeing two issues. One is the quality of data. The other one is the maybe built-in bias in data and something that was not immediately seen before. And then we have this AI engine that needs to process all this, and we need to have some certainty on whatever comes out, that it comes out with a good quality, and we can feel confident that it's correct and appropriate.
Maybe I can add one thing here, because this is a fascinating topic, because everyone sort of agrees on what quality is. And I guess if we talk about it, we can find an agreement as well. But to formalize this in a functional way for an AI system is super, super difficult. And it has many dimensions as well. So in the example that I just gave, I was talking about the basically cloudy image here. But if we think about quality, I mean, if we think about quality of the models are necessarily depending on the data. So that's the garbage in, garbage out aspect that we heard previously about. And here we not only have the sample itself, like the cloudy image or the not cloudy image, we have the label as well. Because we made quite a bit of progress in self-supervised and unsupervised learning, but we are not there yet. So for most engines that we have, we still need labels. And labeling is a very tedious thing, so I can recommend to try it for a couple of minutes. It's not really fun, but it needs to be done, obviously. Another aspect maybe when it comes to biases and to equality, because this is mostly like click working stuff. But the aspect that I want to make, the point I want to make with regard to quality is that the labels need sufficient quality as well. Otherwise you get label noise, and this label noise wouldn't get you anywhere. So it's a very, very tricky thing here.
So definitely more work to do.
When I was listening to Rinkin, and by the way, I think what he's doing and bringing this artificial intelligence to something very simple to the farmers in multiple languages, etc. I think it's fascinating. And you said that women were adopting it easily for some reasons which maybe I would like to understand better. And my question here is maybe to you, but also to Sebastian and maybe Najat. Are you measuring in a kind of scientific way the barriers for adoption of these technologies? Because that's really something in digital world. And when you talk about digital agriculture, I mean, broadly, these are tools that sometimes there are barriers which can be cultural, which can be, I mean, all sorts of barriers that we need to overcome. And I was wondering if, Sebastian, in your research, you are using behavioral science, for example, to try to measure that, or if, Rinkin, were you able to measure this greater adoption? And Najat, I don't know if in IAEA you are also using these kind of techniques to understand these barriers and how to overcome them.
Well, I think we are not yet there to look at the barriers. We are still at the level of providing this technology and look at the output. Is it like, for example, in women in Kenya and Sudan, where we provided this technology to measure the moisture of their soil so that they can manage their water resources better. So the whole thing is about capacity building, is training their women to be confident in themselves and use the tool, which is a small sensor, link it to their telephone to tell them when they should use the water or not. So it's this, the barrier is more, as you have said, is the fear from the digital. We have to put ourselves in a context of rural women in remote area. So it's to bring them to the simplistic way to use the technology and be confident. And once they see the results, they are confident and they share with others. But so we are more on, still on how to build this confidence in themselves and share this technology and then scale it.
The thing I would mention is, on the wide internet, two of the most popular applications that everyone uses is TikTok and YouTube. Videos that are by people and for people that we relate with, including for women to see fellow peer women that they can identify as role models that they might want to learn from for themselves, can be hugely powerful. And then the good thing about this type of use of AI is that unlike in the traditional extension model where you have extension agents conducting training sessions in the field on farmers' plots, it's sometimes very unclear about how many women were actually engaged there, how many women actually went back and applied these practices on their own farms, how much decision-making capacity did they actually have in that process. The thing with the bot is that you actually can see that data in real time with the usage of what questions are they asking? What are they giving a thumbs up or a thumbs down to? And we can then tailor the model to better suit their needs.
Okay. Thank you, thank you. I can see we have 2 minutes left, so I'm afraid we need to conclude, but I'm very encouraged by the social media wall, what we see. We see some strong support to using AI, some questions. I think we were navigating through them already, but if there is something there we didn't cover, we will find a way to respond, maybe using the same wall. It would be very difficult to summarize in detail the rich discussions we had, but I think we can agree that yes, we embrace AI. We would like to take advantage of the technology towards agri-food systems transformation and really what we in FAO call the four betters, but it's really to leave no one behind. So we want to embrace technology. We also realize that it's important not to neglect the responsibility we have of using technology. So we spoke about the data, what data, garbage in, garbage out, but also not only from perspective of mathematics, let's say, and accuracy of the results, but also from perspective of inclusivity and potential biases inside. So this is very important. We've seen fantastic examples, and thank you again for being with us, of Atoms for Food initiative and something that we already have in progress for advancing the agenda on SDGs and 2030. The urgency there, we could see from the DG and also from Chief Economist, there is absolute sense of urgency and encouragement to use digital as accelerator and enabler. So with that, I would like to thank you again for being with us. I would like to thank Alan, who is online, and also all the participants. Thank you for joining us. And if I can ask you for a round of applause for our panelists. And please stay tuned as we continue our journey with the AI. So the session is closed. Thank you again so much.
Very nice to meet you.